Okay, when we've been talking about polynomials and somehow we know that x plus 1 is a factor, um, or somehow we work out that f of negative 1 gives 0, and we know by the remainder theorem that when f of negative 1 is 0, then x plus 1 is a factor. Where did this negative 1 come from? And guess and check is probably not the best answer because there's lots of numbers to guess and check with. It's not perfect, but this is the way to narrow your guess and check. So we get our polynomial there, and we get our constant. And we think of all the factors of that constant. So with 6, it'll be 1, 2, 3, and 6, won't it? Then we get the coefficient of the x cubed term, which is 1, and we think of all the factors of 1. Well, that's hard. Okay. We then divide the factors of the constant by the factors of the coefficient of our x cubed, and they're potential zeros. Okay. So we're going to go 1 divided by 1 is 1. So these are potential factors, and they can be plus or minus. We don't really know. Okay, so 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. And 6 divided by 1 is 6. So instead of guess and checking any number you can think of, the only possible zeros of that polynomial will be 1, 2, 3, and 6, or negative 1, negative 2, negative 3, and 6. And this is example 1 of our synthetic division. And I think our factors were x plus 1, x plus 2, and x plus 3. So 6 wasn't a 0. So if you put negative 6 into here or 6 into here, you're not going to get 0. Because that sort of worked out nice and easy, let's just quickly see if we can do our next synthetic division one, which was 6. So without looking at the answer this time, again, we're going to get our constant. And what are the factors of that? And then we're going to get our coefficient. And here our factors are 1 and 2. So here we've got more combinations. So our potential factors will start with 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. Then we've got to divide by 2. So what's 1 divided by 2? 2 divided by 2, we've already got. 3 divided by 2. And 6 divided by 2, we've already got. And remember, they're plus or minus any of them. So again, instead of just guess and checking random ones, we're going to only guess and check from this potential source of zeros for that polynomial. And if we can remember, that one was an answer and 2x plus 3. So you can see here that there's our negative 1, there's our negative 2. 3 didn't work, 6 didn't work, half didn't work, but there's our 3 on 2. Here's a challenge for you. When we accidentally come across 1 or 2, we're going to use our synthetic division to get our answer here. Wouldn't it be interesting if, for some strange reason, we selected 3 on 2 first and went, oh, f of, well, it's not 3 on 2, isn't it? Because that wouldn't give us a 0. It's got to be negative 3 on 2, which it is. So I reckon 9. That one, if we, for some strange reason, thought we'd try that one and got a 0, here's a challenge. Use your synthetic division here. 2, 9, 13, 6, negative 3 on 2. pull down your 2. See if you can get that synthetic division out using -3 on 2 as your first factor, your first 0.